Right guys, another customer repair. Just thought I'd start making videos on everything. Let me move the chair in a second. What we got is a 500 watt Kugoo M4 clone motor, direct drive. I think I posted a video with an internal geared planetary hub motor. This one's the opposite, it's direct drive, no planetary gears. I'll show you the difference now if you've ever seen the other video. This one came in, motor cable, the usual. Customer attempted tyre change, went through the cable. Funnily enough, this is showing up on the screen, the TF100 display as an error 10 intermittently, and it's not showing the speed. So funnily enough, the customer nicked the one that's actually detecting the speed. The scooter still runs, it's just rough as nuts. So anyway, best option, switch the cable out. What we're going to do though, because it's a Kugoo M4 clone, this cable runs continuously. I've cut that there. I didn't want to take the cable out. It runs continuously through the chassis of the scooter, out through the rear indicators on the right hand side. And when you've got to change a tyre and get this off, you either A, have to unroot all this through the inside of the frame, or B, risk nipping it like this one is, and then you've got to have the motor rewired. It's a cheap enough fix, it's just a hassle, downtime. So what we're going to do, instead of replacing it with one 3-foot long cable to run straight through the chassis again, which when it comes time to tyre change or brace disc change is a bit of a pain in the backside, we're going to change it for one of these. Standard connector that come on the Bafang bikes. We're going to change it for one of them internally straight through there, and we're going to put a connector on the other side of the scooter, so whenever it's time to swap this out, like I said, we can just disconnect the motor there, or the customer can change the tyre nice and easy, avoid damage in the future. The only thing I have done off camera is take the bolts out of there, because that can sometimes take longer if they're rounded off. Use a decent tool, that's the best advice. No cheap aluminium Allen keys, they're not going to get you far, cause more hassle. Something to hold the motor so it's stable. Any roller tape will do. As you can see, the spindle sits in there, that keeps the motor free. I've undone these ones as well, same reason. If any of them are rounded off, it's a nightmare. The video will be 20 minutes long just getting one bolt out. If anyone has any trouble getting any bolts out or they're rounded, there's plenty of easy ways to get it out without hacking it up. Send me a message or message me on WhatsApp and I'll lay in row a few things. So anyway, bolts out. We'll take the cap off next. This has a lip that doesn't sit flat with the internal of the motor, so it's enough just to catch with 2 bars. Raise nice and gently, he says. There you go. Once that's raised, we can lift that off. What are we looking at? On the inside cap is the first bearing. From memory, that's a 6003 RS bearing. That fits that spindle. On the other side, there's another 6003 RS bearing. But if you needed the bearings changed, it's a case of taking off the cap, pulling out the rubber seal with your little finger, tapping out the bearing, tapping the new one in. I will post videos on bearing changes when they come in. Most of the time, if I'm going inside the motor anyway, I recommend a bearing change. This motor, as you can see, is clean. I tested the bearings. It hasn't done many miles, to be honest. Despite the dirt on the outside, inside is immaculate. No rust spots that I can see. The copper's nice and bright, not dull, burnt. There's our sensor board, 1, 2, 3 sensors. This is 120-degree sensor instead of a 60. 60 is smaller, 120 is longer. There's no point doing the math on that. We need to get this old cable out. I'll slow down now as we get into this. We need to get this old cable out. Remove the 3 phases from there. I am going to desolder these from the board. You can cut these, leaving yourself tails. Let's get inside a second. Right, there we are. So the cable is running through the spindle, out through there, and it's connected to 1 phase, 2 phase, 3 phase. Then our 5 wires are our plus and minus for our 5 volts for our Hall sensor board. Then our Hall sensor return signal legs, which is a yellow, green and a blue, which corresponds to the thick cables, which I just pointed out. Basically, as the motor rotates, it sends a signal back to the controller. The controller knows whether the sensor is open or closed, i.e. what magnet it passed last, which direction of rotation, and the speed and rotation, and it works out how much power to pump through the phases to keep the motor sounding nice and sweet. I've explained it before, a Xiaomi runs off sine wave, sounds lovely to the ear when soft starting, but that's the point, is soft starts. And then you've got something like a Kugoo G booster that grunts like crazy off the mark, but is more high torque. Sine wave uses sensors. The torquier grunters just uses the 3-phase. So it's ever a case of swapping out the motor for a normal phase wire with no sensors. That's pretty simple. But I'll zoom in now. What we'll do, we'll get this old cable out first. I think that's for the best. Let's see if I can zoom in a bit. It would save me having to lift the motor and try and juggle. But I'll do for now. Right, first things first, this cable. I'm going to keep some length on in a minute and work inside here. It's usually secured with cable ties. And obviously when we've done the repair and put it back, we do exactly the same, because this is a moving part internally and we don't want the wires going anywhere. What you will find is a lot of rubber seal, which makes things fun. So, right, when cutting these phases to rewire the motor, last thing we do is cut close to the copper bright. Simple reason is, rookie mistake, I cut there now. I will never solder a fresh phase cable onto there. Not even my soldering line running at 480. It just ain't gonna happen. So leave yourself some room to work with. Cut the phases away from the join to the actual copper winding. So there's one out. We dig another one out the second. As long as we don't damage the board, we're fine. Now, if you want going to desolder these from the board, again, clip them there. Give yourself loads of space to trim off. Bring a new wire through, attach back on, heat shrink over the top. I'm going to clip these like that at the moment just to get them out of my way. But I am going to go colour for colour with the fresh cable rather than have an extra join somewhere along the lines. Either or is fine as long as it's secured. It's just, I'd rather send it out knowing that I've run the cable right to the board and there's no problems there. Needs to step together lovely. So we got the yellow one next. Give myself plenty of room, like that. Or give yourself. So we got green and yellow free. Let's dig the blue out. And there's our blue. Right, blue, yellow, green, done. Now the only thing that's holding this motor wire in is the white seal. So we can get that out with some long nose pliers. You can pull the cable through, but remember you've got to put a cable back through there. So if you can free this up now, even better. I'll just take a few chunks of this off. Like that. Make sure never to drop nothing in the motor. When it comes time to solder in a minute, we're going to cover this so we don't get no spray onto the copper bright from the soldering. But right now, we're in easy grounds. I think that'll do for the rubber. Let's get some wiggle out of this cable. It is in there. When the cable's in there, trick, remove one of the phases first. Let me move some of these wires out of the way so you can see. The only wires there now not connected to anything. That's just the cable running straight through. Everything else is hidden. So all them wires are literally just that cable. So if we take one big thick phase wire out, doesn't matter the colour, pull any one out. Let's cut it by ear now to make my life easier. There's less to pull. But usually if we can get one out like that, that frees up the spindle enough so the cable is not under so much pressure inside there. You can go 2 and 3 if you want to. I do like to leave one phase in there though for a bit of structure when you're pulling out the rubber. But we'll just get it out right now. So there's all them gone. There's that gone. I'm gonna grab the bit of the rubber from there and pull him and see if I can get that out. Yay, bit of patience. I move my hands a second, sorry about that. There's the rubber. I've started pulling him. You can see him disappearing down the spindle as I go. Let me take the last phase out. I think that's what's making it difficult. And there he goes. A little bit more. And there she is. As you can see, rust, which means water have ingressed into the spindle, which means if it wasn't for the rubber seal, it would have ingressed into the motor. So obviously when it comes time to this, we seal it back up with seal. And quite frankly, when you get used to doing this, it pays to, with your new cable we're about to stick in, see if I can get it on in the shot. If you cut it flush, put black seal in there first, then push this through, and you've kind of sealed this spindle up so even water can't get inside the spindle and rest in there. So anyway, sit rep, old cable out, leaves us with our 1 phase, 2 phase, 3 phase. There's our board. I've cut the wires. I'm going to desolder them now because I'm going to go colour for colour. Next job, clean this slightly, get our new cable inside. Quick blow out, make sure there's nothing in there. Yeah, looking good. If there's any mastic stuck inside the spindle, 8mm drill bit with your fingers, rotate it down the shaft and you'll draw out the mastic that's left inside. You can grease this if you need to, just to get it in there. Before I poke it in, 2 methods. 1, leave it like that if you can, and it should just go through. Second is to take off maybe 1 inch of insulation there, leaving some wires, and at least you'll get a few phases through. But as you do it, twist the cable and rotate it as you go down if you're going to strip the sheathing off. And it'll kind of corkscrew it and help it go through. Count all the cables have come through, make sure you're not missing no loose hole sensor ones because sometimes they get caught up. Right, let's try and get this from the first method first. I'm going to cut this at an angle, make sure nothing goes inside the motor. Always give yourself plenty of cable to work with in the future. I've pushed down, yeah, you know what, let me take it back out to show that again. I've cut an angle. The angle is, we ain't measuring angles, but let's see if I can zoom in. Just a little 45-degree snip, and I'm going to take that, feed it in that way. There's the hole, and it's going to come round on itself and back through without too much effort. Let's see if I can just do that and stay out the camera's way. This ain't easy, mind, with the camera. But there she is. Right. It's going well. Let me pull this through a second. Right, I'm going to pull it past the point where I need it, just so I've got plenty to work with. Take some of the sheathing off, work out how much I'm going to need. That's what we got. Now, keen-eyed people will notice something. Here's my phases. There's my power for my hall board and my hall signals. It's an extra one there. This cable is for a Bafang motor. Inside a Bafang internal motor, there's a magnet mounted to detect the speed. on this board, this direct drive, it uses one of the holes that's pre-fitted, so we can ignore the white wire. We're not going to use it, so that's going to get clipped straight off. A second, let me rotate this round a minute. Right, so this white wire is never getting used. That's that gone. Now I need to make sure these tails are all going to reach these. So I already know I need to take a bit more off. A second. Not much. Let me remove some more of the sheath in a second. I'll do. And I think that should be it. Get rid of that. I'm not going to need the white. Keep it clean. Now I'm going to drag the cable back through. Only a little bit. Until it matches up with the board. Bit more. A bit more. Bingo. How's that? Let's get our 3 phases out of the way, because we'll be doing them last. Let's move this cable out of the way. So then we got, and actually do our phases first, bury them down there, then come in and tap these last. Okay, let me just make sure that my yellow wire goes to my yellow lengthwise. Got plenty. Blue to blue. Got plenty. They're the 2 extremities. Everything else will be fine. Yeah, we'll do these first. So, last thing we want is any of our solder going in there, or any strands of copper. That's never fun. So let me just take some tape a second. There's no need to have any of that exposed, really. There's no need to have any of that exposed. We're just reducing risk, that's all. No need for any of that. And these magnets are a nightmare to get. Oh, by the way, this is magnetically lined. So if you get a piece of copper strand in there, that's fun getting out later on. I'll do. Now I can have my stand back. Alright, we're sealed off. Let's get some ends going. Oh. Alright, trim a bit of these. Yeah, so obviously this is a 500 watt motor. If I can do a 750 watt cable for one of the geared motors. So there's also plenty of headroom. I just do my head in that dust. Right, one more there. I wish I could find my wire strippers. Might get my nip backs out. I ain't used to them yet. So there's them ones done, which is coming from my new cable. Let me get this debris out of the way. This is like watching paint dry. That one. There's a yellow. And a green. Do. Let's pre-tin everything up. almost home and dry. Let's turn the soldering iron on. That'd be a great start. Zoom back out a minute, have a quick sit rep while the soldering iron is getting warm. Back out we go. Heat shrink. What we got? We're going to double layer this because this fades. So I'll get some heat shrink out cut that ready. So yeah, as you can see, this was a direct drive motor, still is, just covered up. What I mean by that is there's no 3 gears like you see me do in the internal hub that makes the rotation happen. 1, 2, 3. We'll go large with that heat wrap and small with some other stuff. Yeah, try and seal these up as much as we can. Soldering iron's heating up. And it should be good to go. Let me see. Almost. But yeah, if there's any repairs, the numbers across the bottom. If it's something you don't want to tackle yourself, I mean, this is not even an expensive repair, to be honest. The time it takes. Come on, soldering iron, warm up. There you go. I'll tin these a second and then I'll zoom back in. 1, 2. Let's go over here. This does have some nice heat wrap on it anyway. It's fiberglass insulated. So we'll take advantage and use that as well. Is that them all? That's them all. Let's do green first. Don't know why. Let's check that over there. Over there. Let's zoom back in a second. Alright, so green first. Nothing special. Both of them have been pre-tinned with solder. Going to heat up the one I'm not holding first. Here's a pro tip. Introduce the one next to it. Done. Nice join. What we got next? Yellow. I'm going to seal all these up now a second. As long as they don't interfere with each other, I'll chuck them all in one. And just make sure the green's now going to go over there. The rest of this live. Let me get some tape on that first. And then I'll heat gun it. I prefer not to heat gun with the camera on because that's never good. But I prefer to double wrap this with tape, then heat shrink, because it's making contact with the metal inside of the motor. And I do know these heat up inside the controller bag and they turn awful. So let's cover this up a second. Hide it down here. And I'll be heating that up later. Wait there. What I don't want to do is come back on myself later. So let me just heat it now. Quickly. Alright, one down. That's still up. Just bury that in there. And we'll secure that with a cable tie later. So we're one in. Yellow next. And then check some heat wrap on it. But yeah, I think you get the point of this part of the process. Not reinventing the wheel, just fixing the wheel. Heat up the one that I'm not holding first. They will join onto the next one. There are a couple of ways of joining these depending what size cable they are. What you don't want to do is build up a big solder blob on the joint and build up a point of resistance. That is never good. That's the part that overheats from experience. Let me just heat this up again. And ready this one. And something go down there somewhere. Right there. Let me get these wires out of there. Make sure that's in there. There you go. Blue left. Cut that down. Right, blue. Oh, where's that camera gone? There it is. And that just leaves the whole board and the lid back on, really. And that's pretty much done. Let me see, not changing the bearings. Hall sensors are fine, tested them. So it's a case of just that. Again, get some heat shrink on it. I heat it up right here. Also got heat it up the way I am kind of in front of the camera because it makes it flash. But needless to say, that's that then. And we'll secure all this in a minute. What we got left, and then move that, is our one. Let's put these in order a second. Blue goes over there, followed by red, followed by green, black, and yellow. So these are our old wires, and these are our new wires. I think you know the rest. Let me strip something off these first. So we got something to solder with. 1, 2, 3. Come on. One more left. Let me pre-tin these a second. Done. First one is blue. Where's she to? There she is. So let's desolder blue first. Nice and easy. Tap and go on the board. Nothing special. Done. Get our new blue wire. Again, tap and go on the board. Done. Next is red. Should probably guess I do a few of these a day. So that's a nightmare. Next one is red. The board's also marked with the description as well, if you didn't know. Green's next. Where's that black wire gone? There it is, right there. Black wire's buried for some reason. Black's out. Yellow left, and job is a good one. Secure him down. Send it back. Right, that's all of them in. Now we gotta secure it down, seal it up, put it back on the scooter. Let's remove all of this. Make sure there's no debris. There's that solder splat that I was talking about. There we go. Zoom back out. Right, I'll come to you. So, new cable in. 1, 2, 3 phases. They're the big chunky white insulated cables. We put a fresh cable to the board, soldered straight to the BCB, no join. Why would you? Well, you can, but I mean, you're in it, may as well. What's next? Sealant. I am going to seal straight down the spindle, all round, with a grease gun, so it pressurizes it all the way down inside. So that will be watertight. Let's make sure this fits back on a second. Looking good. May as well reattach it now. When you're putting the covers back on, we don't go 1, 2, tighten down all the way, all the way, all the way. Stagger the bolts out. You get even tension on the first 3. When the plate's flat, come in with the rest. So there's them. Let me just get some tension. Bit of tension on that one. Tension on that one. And just keep going around these 3, or the 3 you stick in, until the plate sits flat. That way you know it's even all the way around. You'll hear it click a few times with the spindle sitting back in place. Nothing to panic about. Just keep going round and round. There it goes again. Oh, my arm's killing. I would use the electric one, but that's not going to be no good. Right, all 3 are done. Now you can come in with the rest of them. They should just fly on. Done. Where's the last one? Don't know. Okay, find out in a second. Oh, I see it. One. I'll torque these up with a torque bar. 15 nanometers, Newton meter. Yeah, nano. 15 Newton. Alright, make sure the spindle rotates freely. Yep. So none of the phases are contacting, no debris inside, spindle rotates lovely. Nice plug to disconnect when it's tire change time. So that was a nice one. Right, obviously now the counterpart that needs to be fitted, spliced onto the cable, which would be that side. And then when it comes to tire change, this would be running through the scooter frame, coming out the back, waterproof plug, and then they would be connected together. When it's time to change the tire or a disc, you can just disconnect and change it at the back rather than have to run the cable through. Makes more sense. I'll splice this onto the scooter and shoot a quick test video to show you running tomorrow. Apart from that, that's this one done. It's a quick 20 minutes, which is not bad. Didn't have to change the sensors. They will be coming up. I mean, I've got a few bikes on the side to do. It's just trying to get them to be able to shoot the videos on them, to be honest, is the hassle. It's the space. Plenty of stock to do, no space to shoot it in. So what I'll do is leave you with that. If anyone gets any issues, feel free to message me on WhatsApp. If anyone wants to know how to wire an internal hub, that's how you do it. If you don't want to do it yourself, it's less than a quarter the price of a brand new motor to have it done. So it's a pretty cheap repair. Turnaround is like you've just seen then. If it's posted in, turnaround is pretty much the same day if I get it in the post early enough in the day. It's a 20-minute affair. I always keep cables on stock, various different gauges with different motors. Yeah, apart from that, leave a comment, any questions. I do go around to answering them. If it's urgent, feel free to WhatsApp me a message with a number on the screen, and I'll be able to access you, or at least get back to you more readily if there's more of an emergency, like a battery problem or something. Right, leave it at that, guys. That's a motor, direct drive version, Kugoo M4 clone, pretty much covers most of them. I'll post another video tomorrow.